Hi aspirants, welcome to our current affairs discussion for geography and environment. In this video, we'll be discussing two exclusive topics on geography alone because these topics seem to be important for this year's current affairs. The first topic is about onset of monsoon. In our previous video also, we gave a separate video for showing that this year's early onset of monsoon, and I also asked you to find out the reasons, what could be the reasons for the early monsoon this particular year. Now, the Southwest Monsoon, it has been said by the IMD that it is going to arrive in Kerala by May 27 itself. But actually we know the arrival of the monsoon to Kerala will be by June 1st. But this year it's going to arrive by May 21 itself. Now the onset of this Southwest Monsoon is announced by IMD, that is the Indian Meteorological Department. So how do they announce this? They announce this only after following parameters are met. So we have to see what are these parameters. So one is, the first parameter is the rainfall. So depending on the rainfall. So these numbers you have to just know. If at least 60% of the 14 designated meteorological stations in Kerala and Lakshadweep record at least 2.5 millimeter of rainfall for 2 consecutive days after May 10. So these are some important details. So at least 60% of the stations which are stationed around Kerala and Lakshadweep, they record 2.5 millimeter of rainfall for 2 consecutive days after May 10. This is one condition. This is the first condition. Now the second condition. So what is going to be the second condition? It is about the wind field. The second condition is the wind field. So second condition is going to be wind field. So let us see what is the second condition. The depth of westerlies, please note this down. Most of us who have studied geography, we would think these tropical monsoons, they are related only to the trade winds and of course to the jet streams as well. But here the depth of the westerlies is taken into account. The depth of the westerlies should be up to 600 hectopascals. So what is this hectopascal? 1 hectopascal is equal to 1 millibar of pressure, because normally pressure is measured in millibars, we know that. So 600 hectopascal is the value. So here we know that 1 hectopascal is equal to 1 millibar of pressure. So such like that 600 hectopascal of pressure should be found in the area bound by the equator to 10 degree north latitude. So the value is 10 degree north latitude, and the longitude should be 55 degree east to 80 degree east. So from 55 degree east to 80 degree east in the region of 10 degree north. So 10 degree north latitude, where it is going to be, we know the border of the southern border of India is somewhere around, we know that it is at the nearby to 6 degrees, we know that, right? So where would the 10 degrees be? Somewhere off the coast of Kerala, somewhere nearby Kerala. We also know the 10 degree channel is the one that separates the North Andaman and the South Andaman, and also so 10 degrees is going to be somewhere over here. This is going to be the 10 degrees. So in this 10 degree north latitude region and 55 degree east to 80 degree east longitude region, the pressure should be 600 hectopascals. This is one condition. And the zonal wind speed over this area, so around the area of 5 degrees to 10 degree north latitude and 70 degree and 80 degree east latitude, should be of the order of 50 to 20 knots. So the wind speed should be 15 to 20 knots. So at which region? 15 to 20 knots at 5 degree to 10 degree north latitude and 70 degree to 80 degree east longitude at this region. And during this time the pressure should be 925 hectopascals. Okay, so there are some numbers here to be noted. So please try to note these numbers. So one thing, the westerlies pressure should be around 600 hectopascals. You can see this here. And then the speed of the wind at around this 10-degree north latitude should be around 15 to 20 knots at the pressure of 925 hectopascals. These are some important details that we should know, that the IMD takes into consideration to announce the onset of the monsoon. Now let us see the third condition. The third condition is heat. What is the heat? Here, the outgoing long wave radiation, or simply it is called as the OLR value. And what is this outgoing long wave radiation? It is the measure of the energy emitted to space by the Earth's surface or oceans and the atmosphere. And this value should be around 200 watt per square meters. 200 watt per square meters, and in the region of 5 degree to 10 degree north latitude and 70 to 75 degree east longitude. So in this particular region, the heat value, that is the ongoing long wave radiation, should be having 200 watt per square meter value. So these are the three conditions. So having said about this, just we'll have a look about this outgoing long wave radiation. We have already discussed a lot about the heat budget. We know that the incoming radiation from the sun will be a short wave radiation. Once it touches the earth, it goes back as a long wave radiation. We know that. So you can see here the long wave radiation going outside. So this long wave radiation, or it is also called as the infrared radiation, this value should be 200 watt per square meters. This is the condition. Now there are certain factors influencing the onset of this southwest monsoon. While studying geography, we would have even discussed about the jet streams that are prevailing on the northwestern part of India. They have to go back to the poles. Only then the monsoon will come in, the burst of monsoon happens. Like that, there are some more specific points, and these points we have to note them down here, because such points, such things which are in the news are known to be asked in the UPSC exams. So one thing is, the onset needs a trigger in the form of a weather system in the proximity of the coastline, that is the western coastline across Kerala region. These are ocean-borne phenomena which is responsible for the monsoon surge around the normal time of this onset. Now we'll see what are these. The first condition is the low pressure area or the depression in the Bay of Bengal during the last days of May or the beginning of June. So during that onset of monsoon time, there should be a low pressure area in the Bay of Bengal. So one condition is low pressure area in the Bay of Bengal. This is one condition. And there are such systems in the Arabian Sea also. This you have to note here. We said Bay of Bengal, and sometimes they are found in the Arabian Sea also, because in prelims question it might be asked, low pressure centers are found only in the Bay of Bengal region during the onset of monsoon. And we also know that cyclones happen only in the Bay of Bengal also. We could get easily confused. So the low pressure or the depression regions can be found in the Arabian Sea also, and also around the same time which this results in the onset of the monsoon. And the next one is a cyclonic vortex is another factor which appears in the southeast Arabian Sea. So very important here it appears in the Arabian Sea off the coast of Kerala and this Lakshadweep region, and they also shift along the west coast to push the monsoon current. So this cyclonic vortex, it keeps moving, and this helps in pushing the monsoon current towards India mainland. The formation of a trough off the west coast due to temperature difference between the land and the sea is also important. This is just the normal monsoon. When we learn about monsoon, the first thing we learn is a low pressure area will be created in the land due to the pressure difference created by the huge high temperature during the summer. So this trough also makes a huge role here. You can see here the formation of this trough. And the next one is the cross equatorial flow, where the trade winds from the southern hemisphere cross over to the northern hemisphere. We are not learning anything new here. See, this you would have heard in your geography classes. So normally this, you can see this intertropical convergence zone here. This red color line, you can see a intertropical convergence zone over here. This one, it will be found in this equatorial region. But during the summer, due to the shifting of the pressure wells, ITCZ, that is the intertropical convergence zone, it moves a little bit north, and it is found, see here, it can be found somewhere around the 10 degree north region, that is in the southern part of India. So when this intertropical convergence zone moves to the north, all the trade wind in the southern region, we know that the trade winds, they always go and converge in this intertropical convergence zone. So far they will be converging in the equatorial region, but now the ITCZ has moved to the northern region. So now all the trade winds move towards the ITCZ. So you can see that they have to cross the equator to reach the ITCZ. We know that anything in the northern hemisphere turns to the south or tends to turn towards the south due to this Coriolis effect. We already know this, right? So what happens? From the southern hemisphere, the trade winds which are blowing like this, suddenly when they cross the equator, they turn. And this turn is what causes the wind to blow in the southwest direction, which we call it as the southwest monsoon. So this is one of the conditions. So these conditions, the formation of trough in the western coast in the Arabian Sea region, the wind crossing over the equator, all these things we would have learnt in geography. But something new to be noted here is the low pressure region in the Bay of Bengal, and also sometimes even on the Bay of Bengal region. And then this new thing, this cyclonic vortex, and which should be appearing at the Arabian Sea. These are some important factors which could affect the onset of the southwest monsoon. So because of these effects that we are seeing now, the monsoon is coming very soon this year, an early monsoon from after 2009. This is the first time that the monsoon is arriving early, before June. And let us see this one, the cyclonic vortex. So what is the cyclonic vortex? It is a factor which appears in the southeast Arabian Sea of the Kerala and the Lakshadweep region, and they also shift along the west coast and they push the monsoon current as well. And the next one, we also spoke about the formation of the trough of the west coast. And why is this trough formed? Due to the temperature difference. So you can see here the onset of this vortex. You can see almost at the coast of Kerala and Lakshadweep region. So this vortex is an important reason for the onset of this monsoon. And one more thing is, generally across the world, the monsoons, they are formed only around 20 degree north and 20 degree south. We don't see monsoons beyond these latitudes. And as far as India is considered, it gives around a 70% of rainfall in India. Only 30% is from other ways, due to cyclones or due to convectional currents, convectional rainfall and so on. But the southwest monsoon alone gives 70% of rainfall, an important fact to be noted. And the next topic for today is twin cyclones. So what are these? A pair of cyclones. So why this is in news? Because a pair of cyclones. So what are those cyclones actually here? The Asani cyclone and the Karim cyclone. These two cyclones. So this Asani cyclone is in the northern hemisphere of the earth because we are experiencing it right now. And the next one is the Karim, which is in the southern hemisphere. That is around nearby this Australia region. We can see this two cyclones are there. One is to the north of the equator and one is to the south of the equator. Two cyclones are there at the same time, and that is why we are calling them as the twin cyclone. And you can see cyclone Asani is on the Bay of Bengal, and the cyclone Karim, and it has created a path in the open seas of West Australia. So Karim is found in West Australia. And these twin cyclones, how are they caused? Is they are caused by ROSSBY waves. So can you recall where you have seen about these ROSSBY waves? you would have spoken or heard about this Rossby waves when you have attended the class about the jet streams. The jet streams, we know they are high altitude winds which flow always from west to east. They are high speed winds and they keep flowing in the nearby to the polar regions around the 70° north latitude and 70° south latitude. And during winters, we know these jet streams, they move towards the equator. During winter, they move towards the equator, and moreover they elongate and they form a sinusoidal sort of path. We'll try to explain that. So if you have at any way forgotten, let's try to explain it. So let us say this is the earth and here we have the equator, and we have a very strong wind flowing here from west to east called as the jet streams. And what happens during winter, these jet streams, they take a much more curving path and come somewhere near to the equator. They actually don't touch the equator, but somewhat they come very much nearer to the equator. You can see it here. This is during the winter, and this is during as winter closes towards summer. By summer, this is how the Rossby waves look. By summer, this is how the Rossby waves look. And then again, at the end of the summer, during the closing time of winter, the jet streams, they retreat back to the polar region. When they retreat, these regions, these U-shaped regions, they are left there, they are cut off, and the jet streams alone moves to the northern hemisphere. So the jet streams move back to the northern hemisphere, but here around near the equator, these regions, they just stay and they form something like a vortex, and these are known to form vortexes. And these vortices, they in turn sometimes turn into cyclone if the conditions are satisfying. So now let us see certain definitions. Now Rossby waves are named after a famous meteorologist called as Carl Gustav Rossby, and he was the first person to explain that these waves arose due to the rotation of the earth. So Rossby waves are caused by the rotation of earth. And why they are caused by the rotation of the earth? It's actually a very complex concept which only geography optional students study. I'll just say the one liner of it. When the earth rotates, the water also rotates along with the earth. But at the equator region, since the Coriolis force is zero, the water does not rotate separately. But at the polar region, if you see, the water also rotates when the earth rotates because of the Coriolis effect. But if you see in the polar region as well, even in the polar region, when the water rotates or when the water moves due to this Coriolis effect, the relative movement seems to be zero. The relative movement is on one side the earth is rotating, on the other hand the water is rotating. But when we see the relative movement between these two, the relative rotational movement cancels out each other and it becomes zero. But when there is a movement of this water, when the water present in the polar region, if it moves towards equator, or when the water present in the equatorial region move towards the polar region, these times the water starts to rotate because it sees a sudden movement, and so it starts to give a sort of rotation forming vortexes. And this is how these Rossby waves are formed. This is a huge complex idea, and actually you don't need this for prelims, or in the case of mains, only optional geography students need these. You just have to understand that Rossby waves are something they are formed as a result of these jet streams, and they could result in the form of vortex. These Rossby waves, they are huge waves in the ocean. This is one more thing that you have to know. Rossby waves are over the ocean, not over the land. They are found only over the oceans, and they are their wavelength, a single wavelength would be somewhere around 4,000 to 5,000 kilometers. They are such huge waves. And this system has a vortex in the northern hemisphere and also a vortex in the southern hemisphere, and each of these is a mirror image of the other, because jet streams looks very much similar in the northern and the southern hemisphere, and the vortex formed by them also, they are very much similar, north and south. Now the vortex in the north, it spins in the anti-clockwise and has a positive spin, but the one in the southern hemisphere, the vortex in the southern hemisphere, it spins in the clockwise and it has a negative spin. So please note this down. The vortex in the northern hemisphere, it is anti-clockwise and it has a positive spin, and the vortex in the southern hemisphere, it rotates in the clockwise direction and it also has a negative spin. This is very much similar to the cyclone. Cyclones in the northern hemisphere rotate in the anti-clockwise direction, and in the southern hemisphere they rotate in the clockwise direction, right? Similarly, the Rossby waves also have this similar feature, and both have a positive value of the vorticity, which is a measure of the rotation. See, but though the spin is positive in the northern and negative in the southern, everything or whatever, but they are positive in the vorticity value. So vorticity value is positive for both northern and southern vortices. Now, having understood something about the Rossby waves, now we will see how these Rossby waves are responsible for the formation of twin cyclones. Now, when the vorticity is positive in both northern and southern hemispheres, like how it is supposed to be in the Rossby waves as we saw right now, the air in the boundary layer between the northern and the southern hemisphere, the boundary layer air, which is moist, is slightly lifted. Now let us say you have this earth, you have Rossby waves vortexes here in the northern, and you have Rossby waves vortexes in the southern region, and both have the positive vortex. We know this boundary region air, because of these vortices, could be easily lifted up slightly. When air moves up, we know it will cool down and it will form clouds. So when the air is lifted slightly, the water vapor condenses to form clouds, and as it condenses, it lets off latent heat of evaporation, making it more and more stronger. This concept you have to understand from the formation of cyclone. The formation of cyclone is as similar to that. Those who don't know how the cyclone is formed, there will be a separate video for that, and the link will be in the description. You can just have a look at that to know how a cyclone is actually formed. So similar to how a cyclone is formed, here also the vortex gives the look of a cyclone, like how a normal tropical cyclone is formed. This because of the Rossby waves, also a cyclone is formed, and the atmosphere warms, this parcel of air rises, and a positive feedback is set off by this process. This is nothing but simply the formation of a cyclone, which I will explain in a different video. Now these, as time goes more and more, it forms deeper and stronger clouds, but at the same time the moisture comes in the form of both sides. So you can see it comes from the northern and the southern hemisphere. Now this leads to the formation of a cyclone if conditions are fine. So now what happens? Now because of this cloud forming and the latent heat which is released, makes the clouds more and more deeper and stronger, and at the same time the pushing or the lifting happens from both sides, from the northern hemisphere and southern hemisphere. A twin cyclone can be formed. So do you have to understand everything of these things clearly? No, the one thing you have to know is twin cyclone is formed by Rossby waves. That's it. Rossby waves are present both in the northern and the southern hemisphere. They are present mostly, or they are present on the oceans, and they are formed because of the jet streams. That's it. This will help you to answer any type of question in the prelims, or even manage in the mains also. Now the next one. This twin cyclone was formed not just because of the Rossby waves. Another reason was also behind this, and that is the Madden-Julian Oscillation, or simply it is called as MJO. And one thing you always have to remember is this MJO is a group or a set of air which always moves from west to east. It keeps moving around the earth from west to east, always it's in movement. Now let us see what it is. This MJO It's a large cluster of clouds and convection. So why do we call it convection? You can see it here, that wind is or air is moving from ground to up, and from up it comes down. So this convection action can be seen here. That is why we call it a group of clouds in convection motion. Now this particular wind, it is composed of a Rossby wave and a Kelvin wave. And Kelvin wave, it is a type of wave structure that we see normally in the ocean. So it has Rossby waves and Kelvin waves, two waves. So on the eastern side of the MJO, we have the Kelvin, and on the western margin or the western edge, we have the Rossby waves. And once again, you can see with the two vortices on either side of the equator. Okay, so we know the Rossby waves will have two vortices. So above to the north of the equator, there will be certain vortices. To the south of the equator, again you will have vortices. So on the two sides you have vortices, to the north and to the south of the equator. And on the other hand, you can see this is moving from ground towards the sky, upward motion. So you can see that on both sides there is a movement from the ground to the sky. That is called as the MJO. So however, not all tropical cyclones are born from this MJO. Sometimes simply the Rossby wave with the two vortices on either side itself is enough to form tropical cyclones. But here this particular Asani cyclone and Karim cyclone, they have been formed not just by Rossby waves but from another effect called as the Madden-Julian Oscillation. So simply what you have to know here is, since Madden-Julian Oscillation has come in news, you have to definitely know more about this Madden-Julian oscillations, read more about it, and try to know exactly what are these Madden-Julian oscillations. And that's it for today. If you have any doubts, please put on the comment section. We'll try to give a separate video for that as well, because these topics are a little bit complicated, we know, because it's complete physical geography, climatology, and that too related to current affairs. And we have many concepts like Rossby waves, Madden-Julian oscillation, twin cyclones, and so many. If you have not understood anything, please put on the comments. We'll try to explain it more. Thank you. Jai Hind.